So let's talk about saturation, okay? Let's talk about saturation. When I say something is saturated, what comes to your mind? What do you think about?
Saturated fat.
Okay, saturated fat. But if I say, for example, on Saturday, my carpet was completely saturated with water. What did that mean?
That means the carpet is completely wet.
Full.
Completely wet, completely full of water. Could my carpet absorb any more water?
No.
No. The water was completely absorbed into my carpet. It couldn't hold any more. If it had tried to hold any more, it would have beat it up on top or gone onto other parts of the carpet. It's actually kind of cool to see the video of the carpet because there was like this puddle of water on the carpet that slowly just spread as it went because the carpet couldn't absorb anymore, so it just went out places, right? It's kind of cool to see the video. Well, the same thing happens. Let's say I'm dissolving salt in water, okay? So I've got my little water molecules here, and they're gonna rip apart salt, okay? So I'm gonna maybe put just like a chunk of salt in here. Are there chunks of salt?
Yes.
Yes, okay. So there are a couple things that are gonna affect, number one, the speed that it dissolves. And we're not going to really explore much with the speed of dissolving, but we are going to explore the amount of dissolving, okay? So, but I want to talk about speed. If I just have a chunk of salt, how fast is that going to dissolve?
Not the fastest.
Why?
Because it's like contained, so everything's not getting in contact with the water.
Right. Only these molecules are in contact with the water. So this water molecule might cart one away, and this molecule might cart one away, but these inside are not even having a chance to get carted away, right? They have no chance until these on the outside are all taken away, okay? That's called surface area to volume ratio, okay? How much surface area do I have for my volume? Not very much, right? We're not going to quantify it. But for how much volume I have, I don't have a lot of surface area. If I break this up into a lot of little chunkers, do I have the same volume?
Yeah.
Yeah, I don't have any less volume, but look how much more surface area I have. I increased the surface area to volume ratio. So now all of these are in contact, all of these are in contact, all of these are in contact, all of these are in contact. Okay. So there comes a point though where I've got all these little salt molecules in the water and the water can't hold anymore. The salt's going to fill in between the spaces, but there's going to come a point where the water can't hold any more salt. So we're talking about the speed of dissolving now. What might speed up dissolving? What could I do with this? Because we've got salt up here, but it's way more concentrated down here. What could I do to speed that up? What do you think, Olivia?
You heat up the water?
I could, and it would. But before we heat it up, Braddock, what could we do?
Stir it.
If I stir this, right, here's my spoon, and I stir this, I am so impressed with my artwork today. You guys should be too. So I stir that around, and then I evenly distribute these molecules, right? And so now it can dissolve more quickly, okay? But there's still going to be a point that I can't dissolve anymore. And then once it can't dissolve anymore, it's called saturated. Here's a fun fact for you you're not going to be tested on. Katana brought up saturated fats. Saturated fats have a lot of little carbon atoms that have the places where things could bond to them. A saturated fat has a hydrogen bonded to every one of those, and it's saturated with hydrogens, okay? Unsaturated don't, okay? Hydrogenated oil, you guys heard that term?
No.
Yes.
Hydrogenated oil has hydrogens added to it, okay? So, a saturated solution. Now, Olivia brought up the point, if I heat it up, what can I add more of?
Energy.
Yes. Olivia, what point did you bring up though? If we heat it up, what can we add more of?
Energy.
Not energy.
Oh.
We can add more salt and it'll hold more salt. You guys are going to explore today how much temperature affects how much salt it'll hold. So you guys are going to get it to a certain temperature and you're going to dissolve all the salt that you can dissolve and see how much salt that is. And then you're going to heat it up 10 degrees. And you're going to add more salt and see if it can hold more salt. And then you're going to heat it up 10 degrees. Now, I'm going to recommend add it in small quantities because temperature, depending on what it is, might not affect it as much as you think it would. Okay, I'm just kind of warning you. Spoiler alert, maybe a little bit, but be careful, don't add very much. So when I heat it up, I can add more and I can add more and I can add more, okay? Especially with sugar, I can add a lot more. So I can have, so maybe it can hold this much sugar at 20 degrees Celsius. And then at 80 degrees Celsius,
It's really hot.
it's really hot and it can hold this much more sugar.
Just a ton of sugar.
Just a ton of sugar.
And it's really hot
100,
sugar
it's
water.
just sugar.
Okay, so now
Mm-hmm.
what we're going to do with our supersaturated solution, and this works with some solutions, okay? Sometimes it works better than others. If I kill the heat, okay, so it's at 80 degrees, and I kill the heat and it goes back down to 20, did I take this sugar out?
No.
Okay, sometimes if you have a very clean glass container, that the solute, that sugar, will stay in solution and will not come out of solution. That is called a super saturated solution. And they are very cool to play with because what is happening is you have all these purple sugar molecules, which is not really purple, you know, should not be in solution. At 20 degrees, it can't hold that many. And so it's sitting there going, it's too many sugar, I can't. But it is. Until something happens and gives those sugars a place to come out of solution. And we are going to do that. I'm gonna see if this is cool enough.
Like if we did it to like a
Should I
spoon.
do it? Should I do it now?
Yeah.
This is a sodium acetate solution. It is actually a super saturated sodium acetate solution. The crystals have not come out of solution because they don't have what's called a nucleation site. Okay, is it not recording?
No, you're just almost out of frame.
All right, I'll make sure I'm in frame for this. So they need to have a nucleation site. You have to have something for the crystals to attach to grow. You have to. So there's more sodium acetate in this solution than there should be. Sodium acetate, actually they use in salt and vinegar chips. So I have here a small sodium acetate crystal, randomly prepared in advance, okay? So if I drop this crystal in, it gives a place for the crystals to grow, and you can see how quickly they start to grow. Hey, Tal. And by the time I get back here, the crystals have almost completely taken over my thing. Now, sodium acetate is a crystal that grows really, really quickly. Ooh, oh, Braden, feel it, feel it, feel it.
Is it hot?
It's warm. It's not hot. Feel it? Is it hot?
Energy.
You want to feel it? Who wants to feel it?
Energy.
Whenever you have crystals for me, that's what they produce.
Energy.
They don't produce it. They release
Energy.
You want to feel it? They're cool. Pretty cool, right? I mean, pretty warm, except not. It's pretty cool. This is one of my favorites. Sodium acetate. And And do you see how quickly it crystallized?
Mhm.
That was these were there. Now, how would I get these back in solution?
Heat.
Heat it back up again. I've done this so many times.
Is it fun?
It's fun. And actually yesterday I was playing with it. I couldn't get it to super saturate because it's been sitting on my shelf literally since Christmas. I made this over Christmas break. And it wouldn't super saturate. I kept getting crystal growth. Well, what happened is I had some dust that fell in because it's been sitting on a shelf with an open lid, and it was using the dust as a crystallization site, a nucleation site to be able to form the crystals. So what I did is I filtered out the dust with a coffee filter and got it to be able to super saturate again. So now when I can heat this up for 45 seconds, let it cool back down, toss in another seed crystal, and start it all over again.
And boom.
And I can do it over and over and over. I've done this so many times. So
I kinda
anyway,
wanna-
we are going to be making a super saturated solution.
Let's
We are
Can I please get Harley Williams to check out? Harley Williams
We're,
to check out.
we're not going to make a super saturated sodium acetate solution. We will make a super saturated sugar solution. Okay.
We're gonna make sugar crystals.
We are going to make some sugar crystals.
Can we eat the sugar crystals?
Yes.
Can
Okay. So there's that.
we? Are we gonna make them on sticks?